Let's prove the vertical angles theorem. Previously, you saw vertical angles were congruent. They were congruent. All right, and we were able to determine that based off of a couple linear pairs. Okay, so we studied this when we talked about the different types of angle pairs that we had, and we had talked about how linear pairs are supplementary, and that ended up leading to vertical angles being congruent. What we're going to do now is formally put that together in a proof. Okay, so let's talk about what we actually see here first, and kind of a reminder of how we use linear pairs of angles to come to that conclusion. Okay, so first off, vertical angles. Vertical angles are created when you have a couple of lines that intersect each other. The vertical angles are going to be the ones that are across from each other. So again, calling them vertical angles has nothing to do with like up and down vertical, but it has to do with the fact that these two angles, like 5 and 7, the only thing that they share, the only thing that they have in common is the vertex. So that is where the word vertical is coming from. It's actually referencing the vertex that they share with each other. The way that we had looked at this beforehand, we looked at the linear pairs of angles first, and we talked about them being supplementary. Like angle 5 and angle 6, they're side by side, adjacent, they make a straight line. Those two angles are going to be supplementary with each other. As well, 6 and 7, right? They're adjacent to each other, they make a straight line, they're going to be supplementary. Okay, so now if we start thinking about those pairs and how they add up, right? 5 and 6, they add up to be 180. 7 and 6 add up to be 180. Both of those sums that I looked at involved angle 6. So 5 plus 6 is equal to the same thing that 7 plus 6 is equal to. We should be able to draw the conclusion that 5 and 7 are, in fact, the same size. What we want to do now is formally write this up as a proof. Okay, we want to have our statements, we want to have our reasons that eventually get us to the conclusion that vertical angles such as 5 and 7 are congruent with each other. Okay, so let's go ahead and start with our given information here. All right, line 1, angle 5 and angle 7 are vertical angles. I'll just abbreviate that as VA to make it fit. All right, that is our given information that is given to us. All right, 2, we're going to think about the stuff that led us to believe that these were congruent. Okay, and that had to do with the linear pairs. Okay, I was looking at angle 5 and 6 as being a linear pair, also looking at 6 and 7 as a linear pair. All right, so I'm going to write down that the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees. Okay, and I'm going to have to put the measure in front of it because we're talking about the size of the angles. All right, the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees. Reason for that, these are a linear pair. Okay, so I'm not going to state that they're really supplementary. It's the fact that they are a linear pair, and the linear pair carries the property of being supplementary that gets me to this. So I'm able to just go straight to that equation. In addition, I could go ahead and also write that the measure of angle 7 plus the measure of angle 6 is also equal to 180 degrees. And I can actually keep that as like one line. They're two ideas, they're two statements, but they're the same idea. They're based off of the same reason, so I can just do those together. All right, and 3, what we can do here, we can look at the two equations that we've got set up. One of them says that 5 and 6 together are 180. The other one says that 7 and 6 together are 180. We can take the 180 out as a middleman here, right? It links these two expressions together. It links them together, and we can say that the measure of angle 5 plus the measure of angle 6 is going to be equal to the measure of angle 7 plus the measure of angle 6. I can say that that expression is equal to that one because they're both equal to 180. And that property is called the transitive property. Okay, two things, they're expressions here. Two expressions are equal to the same value, therefore those expressions are equal to each other, the transitive property. Okay, then building off of this equation, what we notice is both of the sides have the measure of angle 6 on there. You can remove that by subtraction by using the subtraction property of equality. You can do that, and when that gets subtracted, we get the measure of angle 5 is equal to the measure of angle 7. And that's pretty darn close to what we want. Right? We want to show that angle 5 is congruent to angle 7. What we've actually demonstrated here is that the measure of angle 5 is equal to the measure of angle 7. Okay, so on a technicality, we need to change this into angle 5 is congruent to angle 7. And we do have a reason for that. The reason is the definition of congruent angles. The definition of congruent angles. Angles that are congruent have the same measure. Angles with the same measure are congruent. That's how we define what congruent angles are. So technicality, we need to change it into what we wanted it to look like up there, and that adds on that one extra step. All right, now for the sake of just doing a practice problem here, we're going to go ahead and take our vertical angles theorem, which we have now proven, which is that vertical angles are congruent. We're going to take that and use that to solve for an x and a y value in a picture that involves vertical angles. All right, so the angles that would be congruent to each other, these two right here, I'll mark them as the red color. Those two are going to be congruent to each other, which means that the expressions can be set equal. The good thing here is that both of the expressions are involving x. If one of those involved an x and the other one involved a y, well, we'd be in a little bit of trouble there. Okay, but this one's going to work out fine because both of those expressions involve the x's. They are equal to each other, and we just need to solve the problem. One thing that I would check here, because you have the 6 that is outside, you've always got that option to distribute the 6 in, but if you can divide the 6 into the other side, you might as well go ahead and do that, and it'll make it go a little faster. Unfortunately, all you really could do is just reduce by a factor of 2. So what I'm going to do is just go ahead and distribute this time, which give us 6x plus 12. All right, now that I have that, I'll look at the two terms that have the x's on it. Go ahead and get rid of the 6x since that one is smaller. So we'll leave that with the 12. We're going to get rid of that by subtracting it. When you take it away here, you get 4x. So you have 4x minus 4 is equal to 12. Go ahead and add the 4 to the other side. 4x is equal to 16. And when you divide, you're going to get 4. You're going to end up with 4 there. All right, so we're going to hang on to the answer. We're going to test it in just a bit here. We're going to test it. Now, one thing that you could do is you could plug it into each of these. Each of these expressions, you can value it. I guess that really wouldn't even take that much time. It looks like you get 36 for that one, and you're going to get 36 here as well. You get 40 minus 4. Okay, so that was fast enough to plug it in. But I want to check something else in a little bit, so I'm going to come back to that. All right, the other two angles that we have, those are also vertical angles. So what we can do is take 16y, set that equal to 18y minus 18. We can do that. Go ahead and subtract 16y from both sides here, because 16 is the smaller of these. That does leave you with a 0. You do get a 0 on that side, minus 18. All right, so we're going to add the 18 on. That's going to move to the other side. You get 18 is equal to 2y, which means that y is equal to 9. All right, we believe that to be an answer. Now, when I plugged in the 4 to these angles, I got 36. I got 36 for that. All right, so let's see what happens when I plug in the 9. Let's go ahead and just do the 9 times 16. Don't have a calculator handy, so we'll just do it here. 9 times 16. Get 144. All right, so I believe that this is 144. That one would essentially calculate the same because you would do 18 times 9, and then you're going to subtract 2 9s for the 18, so you'd get the same number. But we got 144. And does 144 plus 36 make 180? It does. It adds up to 180. And that's what I wanted to check at the end there. It's one thing to plug the variables back into the original expressions you used and see that they turned out to equal each other. But you also get the opportunity here to check both of the different types of angles that you get and see if they truly add up to 180 degrees.
Later, blah.